Good afternoon, everybody. Welcome to class today. First of all, let me just say, wow, I decided to put on the chill station instead of the usual more up-tempo stuff, and it's kind of drugged down the energy just a little bit, so we have to try to fight through it, get the energy back up so we can have a good class today. So that's going to be the plan. We're going to start talking about dictionaries here, a dictionary in Python. But I've got good news for you. And that this is a 2-week module. You might need 2 weeks to do it. You might not. That's fine. With a 2-week module, it might also give you some good opportunity to kind of get caught up for some of you who are a little bit behind. That's fine. We have our opportunities to get caught up. This 2-week module could probably be done in one if you put your mind to it, and we've got spring break coming up as well if you need some more opportunities to get caught up on stuff. These are your best times. But it's a 2-week module. That means nothing's due this coming Sunday. It's all due next Sunday, which is pretty good. Gives us some more opportunities to talk about stuff. And that also means that this week's live stream can be a little bit shorter. We don't have to go the full hour plus. We can, come in at about 40 minutes, 45 minutes or so, and be good, because we can pick up next week and talk about more stuff. And one of the things I'd like to do as well, that I like to do when we have these sort of 2-week module opportunities, is I'd like to request that you go ahead and start looking at things, start reading, start trying to go through some of the material, so that, if there are certain things you don't understand, since there is another live stream between now and the time the module is due, send me an email, let me know about the things that you don't understand, and then I can cover them more in next week's live stream, along with doing a more fully fleshed out sort of program. So that's going to be our goal for this week and next week as we talk about dictionaries. But before we get into dictionaries, I want to talk about something slightly different, something that you might need as we approach the challenges and problems that we can solve with dictionaries. I'd like to start with talking about global variables. Global variables. Variables in our main, variables in that particular file, right? We know about main here based on what we know about the main gate. And, I'd encourage you all to go back and watch that video I posted in the Blackboard announcements yesterday, where I talk more about the main gate and explain that a little bit more. It gives you a little bit more insight about what this is and how it works. But main is just, that particular file. That particular file gets set up with, by default, the interpreter sets it up with the name of main. So when we're talking about variables in main, that's what we're talking about here. And we sometimes call these global variables because they can be accessed from any function. So unlike local variables, which disappear when their function ends, if we have a local variable that's inside of a function, we've said that those variables inside of a particular function are scoped to one function and one function only. But variables that we put out in main can be accessed by any function. And so we call them global variables because they persist from one function to the next. They're across the globe of our main, if you will. And one of the things that it's common to do here is it's common to use verbose. Or skipped ahead of the example, down a couple lines. Those chill beats got my energy all messed up. But let's common to use for flag variables, for our Boolean variables, like we see here with verbose. we can set a Boolean variable at our global level, and then we can use that in different functions to check to see if we have a condition marked to true or false. So like we have here in our example, we have a global variable of verbose. We have it set equal to true. And then we have another function that says if verbose will print running example 1. And so we can kind of look at this in terms of our code. Right, so let's go ahead and jump over here to a REPL. Full screen this up. Let's add the stuff that we're used to adding, right? Here, let's add our shebang. And let's go ahead and put our main gate in there. If just like that. And we're going to create a variable, and we're going to call it, just for our purposes here, for this little demonstration, this will be an integer variable. We'll call it num, and we'll set it equal to 12. Totally arbitrary, totally just something that we just made up right offhand. And so we'll take our function, and we'll define our function. We'll call this one print underscore num. We'll give it an argument of n. Or actually, we'll leave it argumentless. And we will just print the value of num. And so if we add so this is a void function because we're printing directly out of this function. So if we add a call to this void function, print num in main, we can run this and we can see we get our number out of here. So things that are at the global level like this, things that are outside of any function but still listed, in main, kind of at the top of main here, they can be accessed by any function. So even if I wanted to print, make another function, def double underscore num, then I can print num times 2. And so we can do all of these inside of our main gate. We can call all of them double num. Every function can access that global variable, no problem. Now, where the problem arises is if we need to reassign this function, or this variable rather. If we need to reassign this variable inside of another function. So let's say in my double num here, I want to set num equal to 6. And so what I want this to do, and well, that's not a good example because that's going to... Let's set it equal to 24. Why not? So now what we've done here is we've not reassigned this variable. When I run double num, it's not going to make this 24. What we've done here is we've created a new local variable inside of our double num function that is 24. So now if we were to try to do this, what we would expect to get here is 12, 48, 12, because this num value isn't going to change, which is exactly what we get. So when we're using our global variables, the problem arises when we want to change the value of our global variables inside of a function. And as we see here, it doesn't, simple reassignment doesn't work because what we're really doing here is we're creating a brand new variable. We're creating a new local variable instead of a global variable. So what I need to be able to do is I need to be able to tell my program, when I say num, I mean num at the global level. So if I not only want to get this result, but I want to change this value, I need to let my function know what I mean. So I'm going to add a simple line in here that says global num. Just like that. And that's what I need to do to reference this as a global variable. So now what's going to happen when I run this double num function, it's going to see this global num. So it knows when I say num here on my line 11, what that means is this is not a new variable anymore. This is a reassignment of this variable because we're using num from the global scope. Global num. So now, if we kind of look at the flow of execution for this program, we can see we have print num, and print num is going to run this function here, so it's going to print num. At the time it runs this function, num is going to equal 12. Right, so we should get 12. Double num, in this case we're using global num, we're reassigning the value of our global to 24, because we've imported our global num into this function. And then we're going to print out num times 2, which is going to give us 48. And then we're going to print num. And since we reassigned the value of num here in our double num function, instead of 12 now, our global num variable, which is what we're referring to here, is going to be 24. It's going to be this. So on our output here, we should expect to get 12, 48, and 24. Because now here we're using the global num instead of a local num. Remember before, we got 12, 48, and 12. Because with the way we had this set up without using our global num keywords here, this never got touched because this variable was only scoped to this function. So now we should expect this to be our output. So we'll just give this a little run. 12, 48, 24. So we're able to reassign the value of a global variable this way. And this is going to be incredibly useful to us. Incredibly useful to us, especially when we're getting into something like dictionaries. You know, when we're thinking about this in terms of lists and dictionaries, these mutable data structures where I might want to change a value or change part of something or add to something that I want other functions to be able to read and print out, utilizing them on the global scope and being able to import them into our other functions is going to be absolutely critical. Because, you know, you want to be able to have one list, or you're going to be able to want to have one dictionary that you can use to pass data values back and forth. And you might have a half a dozen different functions, and we want to make sure that they all use that same list or that same dictionary. So we can use these globals to be able to do that. And that's ideal. So as we approach this, we'll throw the slideshow back up here, and we have some other slides here that we'll just kind of go through because you've seen the example now, so I don't really need to get in depth with these slides. We'll just kind of run through them. Again, you know, just so you can see it in a text format. If you're keeping notes, you can kind of write these things down. If we need to reassign that global variable inside of a function, we have to declare the global variable before we use it. So here we see an example with a Boolean variable where it started at the global level as false, and then inside of this function, we're changing the Boolean value to true. And we can only do that at the global level if we add this global reference in here. That way our interpreter knows, when they say been called here, or when they say num, like in our little program example that we were just doing there, we mean the one at the global level and not the one at the local, and not something at the local level, which is super important. So that's using global variables. Using global variables is relatively simple, right? But it is something that's going to come in handy, especially as we approach some stuff that we're doing. It's going to give us the ability to do some interesting problem solving and help us out in terms of what we need to do. So now we can kind of move on to the next thing, which is talking about dictionaries. And our dictionaries are going to be really similar to what we examined when we were examining lists last week. So if you'll remember back to last week, we were talking about lists, and we had this sort of data structure where we were looking at lists as sort of a container in a way that we think about variables. Variables as being a container. We can take data in, we can put data in, we can take data out. And with our list, we're kind of looking at our container as a container full of containers. And our dictionary is going to be very simple, with one special catch. In other programming languages, you might be familiar with the idea of an associative array or a hash table, to where we have one data value that associates with another data value. So you have what we call a key value pair. And that's what we're working with a dictionary. Right? So that's the big difference between our dictionary and our lists. If you remember back to last week, we were talking about our lists, and we said that we kind of traverse our list and access different elements in our list in a similar way that we access stuff via, string manipulation or whatever. We have our index locations, so we can number things 0, 1, 2, 3, like in our example here. But with a dictionary, we're not thinking about our elements like this. In order to access these elements, every element has a key, and we can kind of put a little keyhole here on each of these data elements here. We have a little lock on each of these We'll say those are keyholes. We have a little lock on each of these data elements. And in order to access the data inside of that data element, we need to have the key to be able to unlock it. So with our dictionary, we have a set of key value pairs. And keys can be any immutable type. So any of the primitives or a tuple, which we haven't really talked about tuples. We're not going to talk about tuples. That's sort of outside the scope of the course, although it might be interesting to do tuples as a data structure. That's for another time, maybe a more advanced class. So when we're thinking about keys, keys can be any primitive or anything that's immutable. So we can use a string for a key, we can use an integer for a key, we can use a floating point number for a key, we can do just about whatever we want to make a key. But the big point here is that keys are immutable. And we'll talk more about why keys are immutable here in just a moment. But these keys are immutable. And the values can be any type. We can have lists, we can have strings, we can have whatever as the value here. So we have a key that is immutable, and we have a value. And this value can change. So the key is kind of the lock to get inside of the bucket, to gain access to this data. And the value is the data that's inside of our bucket. And a single dictionary is heterogeneous, like our lists that we were talking about last week. We can take different types of data values and store them in a single dictionary. Your mileage may vary in terms of finding a solution for a problem that would make sense to use this. But it is an option. And you can define, modify, view, look up, or delete the key value pairs in a dictionary. And as we've already said, you might hear them in other programming languages as an associative array or a hash table. It's also a way to get a switch statement if you're familiar with a switch statement from either JavaScript or Java or something like that. It's a way to get a switch statement into Python, sort of. It's not exactly the same thing, but you can use it in conjunction with a little bit of other code to get some switch conditions. Which is pretty interesting. We might look at that a little bit later. Probably that might be more of a next week thing as we're approaching doing more advanced programmatic stuff with dictionaries. But the big question here is that we said that the immutability of keys is super important. So why then are keys immutable? Remember that immutable means unable to be changed. And you can kind of think about this in terms of the keys that you're used to. Right? Your car key, your house key, whatever. You've got a key. That key is something that gives you access to what's inside. Or, it allows you to get in your car, it allows you to start your car, it allows you to get in your house, get in a mailbox, get in a safe, get in whatever. It allows you access to an element. It allows you access to value, regardless of what that is. But what happens if, by accident or unbeknownst to you, something changes about the lock? Maybe somebody rekeys a lock, or maybe something gets broken or in the lock to where the key doesn't quite fit anymore. What happens? Then you're not able to access what's inside. You can't get in because your key no longer works. So when we're talking about the immutability of keys in terms of Python dictionaries, our keys have to be immutable. We can't be able to change our keys because we still want to be able to access the data that's inside of that data structure. I mean, think for a minute, like what if you accidentally changed a key in a program? If you accidentally change a key in a program, then you can no longer access the value that was once associated with that key, because now the key is something totally different. And it allows us, and it causes us to lose our point of reference. Because these keys are not only, what unlocks the access to what's inside, but they're our point of reference. So if we have a dictionary that's, maybe numbered or whatever, and then all of a sudden we change a value or add in a different value that we didn't expect, we wouldn't have that frame of reference to be able to refer to get information from our dictionary. We wouldn't know how to do it. Our interpreter wouldn't know how to send it back to us because we wouldn't have the right key to be able to get access. So when we lose that point of reference, this breaks the entire dictionary, breaks everything. Because once that reference point's gone, you're done for, right? You can't, you lose that point of reference, you lose it for everything. And so that's why, as the originators were creating Python, they were looking at this idea of the dictionary, and they said, you know what? You shouldn't be able to change the keys. The keys should just stay static. Unchangeable. That way we can always keep that frame of reference. We can always have somewhere where our users, where our developers can be able to access the values unless they, without them, making mistakes, right? It gives us, the opportunity to correct our own mistakes or not even make a mistake at all. It takes away one of those avenues for mistakes. Which, for those of you who will be in my web design class, that should be something, that'll be something that you hear about in there, is how one of the points of good design is our guiding, it's about guiding your users down a path where mistakes are mitigated. Whether you've set things up for success where they won't make a mistake, or you've given some options for people to correct their mistakes. So that's just good design in our programming language here, which is great. We take this ability away to make mistakes because we can't accidentally change our keys because they're immutable. Now, before we write a dictionary here, which we are just about to, I want to highlight a couple things. One, keys must be unique. So every key must be perfectly unique in order to work. Right? Like if you have the same key for two different locks, it won't know what you're talking about. Because what you're saying is use this key, and it's going to be like on what? On what? It works here and here. What do you want me to open? And when all you're saying is use this key. Not good. Assigning to an existing key will reassign the value of that key. So if we want to change the value that goes with an associated key, we can do that. We just can't change the key. And then dictionaries are unordered, meaning we can add anything in any location. So I've got another slide here that just kind of explains things, but you know what? I think it might just be better for us to just go ahead and write some code, because it's been about 10 minutes, about 10, 15 minutes now since we last wrote some code. So let's just write some code here. I'm going to go back to that REPL that I have here. And for my purposes, I want to keep this, but I don't need it anymore. So I'm just going to kind of hit enter, push it down to the bottom, and comment it out. That way, when you guys get this demo file, it'll still be in there for you to refer to. But we don't need it for this part of the program, so we can just kind of push it on down. Let's push it down a little more. and comment it out. And so let's create ourselves a dictionary. And so last week what we did was we looked at lists. And when we're looking at lists, we're looking at something, in a very similar way to what we're looking at when we're looking at dictionaries. So let's start off by writing a list. So let's make an item list. And we could set it to some of our grocery store items, some of the things that we need to buy from the grocery store. So let's apple, banana, carrot, and we can't be too healthy. Let's go for a donut. So we have this list. And as we've discussed, we access the items in this list by referring to the list plus its index location. So we have these 4 list items here. They have index locations of 0, 1, 2, and 3. So if we wanted to refer to banana, we would refer to it as item underscore list index location 1. And if we printed that, that would give us banana. But again, we're moving on to dictionaries. So now let's take this same sort of list and change the way that we think about it by putting it in a dictionary. So we'll create an item underscore dictionary. And we'll set that equal to in curly braces. We don't use braces very often in Python. The print format statement, we use braces. And our dictionaries, we use braces. And those are the only 2 applications of the brace in Python that I can think of at the moment. But what I like to do is I like to put one dictionary item on each line with its key and its value. So we'll say, we'll give it a key, item 1, have it a colon to separate between key and value, and apple. Item 2, banana. Item 3, carrot. And item 4, donut. So let's point out some things now that we're here. All right, what we have here is we have our key value pairs. Right, on our left-hand side of our colon here, we have our key. So everything on this left-hand side here, these are our keys. And everything on the right-hand side of our colon here, these are our values. And so when you have a key with a value, that's a key value pair. Now things to notice here is that we have commas separating each item in our dictionary. The only place where we don't have a comma is after the last one. If you put a comma there, it'll throw an error. So after every dictionary item, except for the last one, we put a comma. And we put a colon to separate our key from our value. And remember that these keys and these values can be almost anything. Our keys can be strings like they are here. They can be integers. They can be floating point numbers. Does not matter. And our values, likewise. The only difference is that our values can also be lists. So since we're thinking about this in terms of lists, let's kind of write a little bit of code to try to access some of these items in our list just to see what we get when it happens. So I'm going to go ahead and add our main gate. just for consistency and good practice. And what I'm going to do is I'm going to use one of those for in loops like we were looking at last week. So we'll say for item in item underscore dictionary. We'll just start out by printing the item. So let's see what this gives us when we're looking at it this way. So we're just going to iterate through our dictionary, and we're going to print out every item that's in our item dictionary. Let's see what it gives us. Item 1, item 2, item 3, item 4. So what we get by default are the keys. So this gives us the keys when we're iterating through our dictionary. You see that it does not give us the values that go along with those keys. How do we get the values? Well, let's comment this out for a minute. We'll come right back to this in just a moment, after we analyze how we access a particular element in our list here. So if I want to print out what the value of item 3 is, I'm going to print item dictionary, the dictionary name, and in my square brackets, instead of an index location, I'm going to put my key, item, which is item 3, the string. And this might actually be easier for some of you to kind of wrap your head around than lists were. Right? Because we're not talking about index locations, we're talking about a specific name that has a relationship to a specific value in this dictionary. So if we print this out, we get carrot, which is great. So now we have this understanding here that if we want to access a value of a container, if we want to open up that container and get it out, remember that data is kind of locked in that container. So we need that key to be able to open up that container and get that data out. So now what if we go back here and look at this statement again and figure out how we can print all of our values. So we know that for item in item dictionary, that iterates through our dictionary and gives us all of the keys. So if we write a similar formatting to what we wrote here and say item underscore dictionary item. So now what it's doing is it's iterating through my dictionary, grabbing each key, and it'll stick the key in our reference slot here and print me out the result of the value of that associated key in my dictionary. So now with this for in loop, what I get is I get the values instead of the keys. Apple, banana, carrot, donut. Pretty nice, pretty nice. And if I want to change one of these things, well, all I have to do is just change, reassign the value of the item that is associated with a particular key. So let's say, I start kind of feeling bad about myself. I shouldn't have got those donuts. Right? Need to change it. Need to make it something else that's a little more healthy in my dictionary here. So we know we can access that dictionary item by focusing the dictionary and examining that particular key. And so all we have to do here is we have to reassign this another value. So remember, we're not changing the key here. That key is untouched. We're just using the key, opening it up, taking the data value out, putting a new data value in, and locking it back up with the same key. It's kind of like having a post office box or some kind of a locker, right? Like you open up the locker, you take your stuff out, you put some stuff in, you close the locker, you're good to go. Right, so now if I run this, I'm reassigning the value of item 4, and then I'm getting for item in item dictionary, we're going to print the item. We're going to print the value of each of our keys. So now instead of apple, banana, carrot, donut, I should expect to get as output apple, banana, carrot, celery. So let's check this out. Apple, banana, carrot, celery. Good, good, good. And, we could even take this a step further, and we could start to use things like input statements. So we've kind of got this understanding of how to iterate through and go through everything. So that's all well and good. But what if I wanted to get an item from my user, or what if I wanted to check to see if something was in my dictionary? That might be something good too. For that, I need this back. Let's create an input statement. So we'll create a variable. We'll call it selected. And we'll set it equal to an input of enter grocery item. Okay. So that's all well and good. So now we'll iterate through our list. We'll see if any of the keys have the value that was selected. So we'll say if item dictionary square brackets item equals selected, we'll print item in dictionary. So I think this is a good way to kind of get us started here. And there are definitely other ways that we can do this that we'll talk about next week. But, I said we wanted to be a little bit shorter this week, so we can kind of stop this here. So what we'll do is we'll just run this code. We'll talk about how it works. I should be able to enter an item. And if it's in there, we can say, well, we'll print the item in dictionary. Else we'll say we'll print not in dictionary. All right, so we're iterating through every key. We're looking at every value behind every key in our dictionary, and we're going to see if one of them is the same as the input here, where we're entering a grocery item. If it is, we'll get that the item is in the dictionary. If it's not, we'll get that it's not in the dictionary. So we'll enter grocery item, we'll enter apple, and this should tell us that the item is in the dictionary. Item in dictionary. Now what we have here, the problem here is that we're still doing it for the loop. So this would be a place where, like, if we were being smarter about it and refactoring it, it's checking to see if it's checking for every item to see if the item's in the dictionary. So what might be smarter for us to do here is to use some kind of seed variable to fix this. Or we can have something like in underscore list, set that to false. And then we can say if the item's in the dictionary, we will set n_list equals true now. Then we can write another statement here. If in list print item in dictionary, else print not in dictionary. So that's going to solve that problem where it, is going through everything and checking everything. Right? In this case, what we're doing, if there's one thing in there that, if it matches, we're going to change this flag variable from false to true. And then we'll print out in kind. So now, instead of this nonsense, we can run this apple. Apple's in there. We're going to get item in dictionary. We get it one time because we did it right. And if we enter something like grape, we get a not defined. We can fix this. What have we done here? That's strange. Let's change this to an LF, see if this works. LF not in list. Or LF in list is false. Oh, what have I done here? Because the affirmative is working. And I know some of you are out there probably screaming at my typo or whatever error that I'm making here because it's not registering with me at 2:48 in the afternoon. Let's see here. Else. Continue maybe. Yep, there's the typo. There's the typo. How many of you were screaming at that? Probably all of you. Else, print not in dictionary. Enter grocery item, grape, not in dictionary. There we go. That's what happens when you get on a roll and you put a colon instead of an equal sign. I'm sure all of you caught that as I was doing it, and there were no issues. So I'll send you this file when I send out the recording today, so you can have a look at this file as you are watching the video again, or working on whatever you need to work on. Remember, this is a 2-week module, so things aren't due until April the 4th for this module. So you got a little bit of time, although I do kind of recommend to kind of start on a little bit early. That way, if you encounter anything, run into any questions, you can ask, and I can cover them next week. In addition to the other stuff that I'll be covering. So next week we'll be looking at adding to and removing from a dictionary. different ways to access a dictionary, and we'll do some larger programs so you can see dictionaries kind of in action. So that's all that I have for you for today. I'm going to turn the upbeat music back on and hang out in the chat for just a couple minutes, just in case anybody who's with me live has any questions. But that's all for you for today. Thanks for watching, and we'll see you next time.